So I have a situation set up here. I want to multiply this monomial 2x by this polynomial x plus 3. And I'm going to talk about this two ways as always. First of all, we're going to take the visual approach, the area approach of a rectangle, and think of our 2x as the length, our x plus 3 is the width, and if we multiply length times width, we get the area of our rectangle. And so the answer to this question is going to be represented by the area of the rectangle I'm going to create below. So if I want to lay out my length and my width along my axes here, I need 2x as my length. And along for my width, I need an x, which I'm going to have to turn sideways, plus 3 1 units. Okay, so I'm setting up my dimensions. Here's my 2x, and here's my x plus 3. And the rectangle we're building is on the inside as always. And I can get individual subdivisions if I just extend from the pieces on the outside of the bars. And so the area of my rectangle in blue is made up of the pieces that I see. Well, I can see if I try to fill those sections in that I have 2x squareds. So my area is going to be 2x squared plus 6x's. So I put my x strips in. That makes up the area of the inner rectangle. And so I add plus 6x. There's my product, which is representing my area of my rectangle. In terms of how I could multiply this algebraically, I can distribute my monomial to each term and multiply. And so let's just write this out over here. That would be 2x times x plus 2x times 3. And when I multiply 2x times x, I'm going to add the exponents on the variables. So that's 2x squared plus 6x. So I've represented my product visually as the area of a rectangle and done it algebraically using the distributive property. All right, let's do a couple of examples algebraically. We want to multiply this monomial by this polynomial. And so to do that, we're going to distribute the monomial to each term here. So negative 3x times x squared, negative 3x times negative 2x, and negative 3x times negative 3. And we'll work each of these sections out. If we multiply here, we're going to add the exponents in multiplying the powers. So that's going to be x to the third times negative 3 in front. Here we're going to have negative 3 times negative 2, which is positive 6. And if we multiply the x's, x times x will be x squared. And here the negative times negative will be positive 9x. And we're finished here because we do not have like terms. We have the same variable but different exponents. So that is our product. Now, just while we're at this question, remember that I could write the question in reverse. I could take my answer. I could be given this and asked to divide by negative 3x. And I know that I should get that as an answer. So if I'm given a division question by a monomial, it's reverse distribution. It's just dividing the monomial in the denominator into each term in the numerator. So I can write that out like so. And then I can divide each section. Negative divided by negative will be positive 1. X cubed divided by x to the 1, we subtract the powers. So I get x squared Dividing here, 6 divided by negative 3 is negative 2. Dividing the powers, we subtract the exponents, x to the 1, and here 9 divided by negative 3 is negative 3, and x divided by x is 1, and so I get my quotient. Finally, here's an example that involves multiple steps. The first thing we need to do is multiply this constant through to our polynomial, so we will do that via distribution. And then we have minus another section that's multiplied, so we have to multiply this monomial to the x plus y. We do multiplication first. So if we multiply the 3 through with distribution, we'll get 3x squared plus 3xy plus 3y squared. And then if we distribute the negative 2x through, remember the negative attaches to the 2, so we're multiplying negative 2 through. This times this will be negative 2x squared, and negative 2x times y will be negative 2xy. Alright, so I've completed my multiplication. I now have to combine like terms if there are any, and x squareds have the same variable and exponent, so they're like terms. So if I take their coefficients, 3 minus 2, that would be 1x squared. 3xy and negative 2xy are like terms because they have the same variables and the same exponents on those variables. I have x to the 1, y to the 1, x to the 1, y to the 1. So I can collect them. 3 minus 2 would be one of those, so positive 1 xy. And the 3y squared is on its own. There's no other like terms to combine with that, so I add 3y squared, and there is my simplified answer.